Okay, so here is the correction on number 14 in section 1.1. So Kendall Porth, one of your classmates, found the error. So we have, okay, so 4y double prime equals y. So in the video, I only took one derivative instead of two. I forgot to take the second one. So if we, okay, do this again. So our solution that they want us to verify was e to the rx, right, where r is a constant. So if we substitute our y, e to the rx, right, double prime equals e to the rx. Okay, so I took the first derivative. Well, let me actually rewrite this like this. I don't think I did it in the other one. I think that's why I forgot. So 4 times, okay, the derivative of this guy, so e to the rx is e to the rx times the derivative, right, of the inside function, right, using the chain rule. So that's just times r, which I did do in the video, but I forgot the next step. So let me write this, and I'm just going to go ahead and write the bracket so I won't forget to take the other derivative. Okay, so now again, r is a constant, so that's just going to stay. So I have the derivative, right? I want to take the derivative of this guy, which we already did, right? It's e to the rx times r, but times this other r that we obtained from taking the first derivative. Okay, so this is what I forgot in the last video. So thanks to Kendall Porth, who will get one extra credit point for correcting me. So let's just solve this differential equation for r. So we have 4 times, okay, so we have e to the rx times r squared equals e to the rx. And I'm going to go ahead and subtract. Okay, so this is what I'm doing here. I'm subtracting e to the rx from both sides. So I get 4e to the rx minus e. Whoops, I forgot my, let me erase that. I don't want to make another mistake. Oh, I don't know why this eraser function's not letting me erase. Okay, so let's cross that out. So I have 4e to the rx r squared minus e to the rx equals 0. And so think of when you solved quadratic functions, right, it has to be in standard form, so that's why I'm setting it equal to 0. And I'm doing this because I noticed that I can factor an e to the rx. So I did this again with the last problem, but again, I forgot this was r, and it should have been r squared. So if I factor e to the rx, right, it's my GCF, I'm left with 4r squared minus 1. And I have, well, I can use the zero factor property, so e to the rx equals 0, or 4 minus 1 equals 0. Now, this is never true, right? I drew a graph on that in the last problem. So this is never true. Right, e to the rx is never going to intersect with the 0, the horizontal axis. And if we solve for r here, and again, I'm, right, don't want to forget that too. So I get, if I add 1 to both, well, there's 2 ways you can do this. It really doesn't matter how you solve this. If you want, you can say this is a difference of 2 squares. And you can say 2r minus 1 plus 1, right? From algebra, we know A squared minus b squared is a plus b times a minus b. All right, this is a difference of two squares, right? 1 and 4. And then, of course, just set each factor equal to 0. So if we solve for, that's an r, we get 2r equals 1. So r is a half, and then similarly, r equals negative 1/2. So these are the two solutions. If you don't want to use the difference of two squares, you can do, you can use the square root property, and you have, you can add 1 to both sides, and then we can divide both sides by 4, right? That's a big 1. R squared equals a fourth, but I can take the square root of both sides, but remember when you take the square root, you have to add the plus or minus. So r equals plus or minus 1/2, right? Which is exactly what we got when we factored the difference of two squares, right? These are the same. This is just a short way of writing, you know, 1/2 and negative 1/2. So that's the correction. And one thing another thing I wanted to say, if you wanted to use a quadratic formula, you can, but it's not necessary. This is a lot easier, but again, if you want to use it, that's fine. Okay, so that is the correct solution to number 14 on section 1.1. And again, if you find any other errors, I will give you an extra credit point.